Hello, folks. My name is Mark Krawczyk, and I am just going to share a brief introduction to Keyline in advance of our upcoming Keyline design workshop happening through the American Farmland Trust this coming Sunday. So I'm just going to launch right into it. I'll be sharing my screen, and we'll get right to it here. So, in the next, well, 45 minutes to an hour or so, we'll just be looking at an overview of keyline design and patterning. And I always like to start this off just acknowledging some of the people that have been really impactful for me in my learning journey along the way. Back in 2007, I took my first keyline design course with Darren Doherty, who has really done an incredible service to the world, to the agricultural world, and helping popularize a lot of this, often sort of niche and somewhat hard to access knowledge. He's built up an incredible body of work in his career, and will likely continue to do so for the next few decades. And just been a real inspiration to me in helping unlock the work of P.A. Yeomans and Alan Savory and Elaine Ingham and a number of other real leaders in the regenerative agriculture world. The foundation of the information we're exploring in this talk um, is something generated by P.A. Yeomans, and we'll get into that briefly in just a moment. But just a short little overview of what this talk will consist of. We'll do a little bit of an introduction, talk briefly about some of the history and background on Keyline, offer some definitions, then we'll look at the scale of permanence, followed by the geography of Keyline and Keyline patterning, some of the basics of subsoiling, and then how Keyline can be used to inform farm planning design. And then last, I'm going to share a tool that you all can use, um, at least to give yourself some very valuable baseline planning data that you can bring with you to the workshop to foster some discussions down the line. So first and foremost, um, you know, major acknowledgments to P.A. Yeomans, Percival Alfred Yeomans, and the entire Yeomans family for the work they did in developing this keyline concept in the post-war era in Australia. Yeomans himself was a mining engineer and also a farmer who had developed kind of intuitive capabilities to, understand the potential for different sites to support mining activities. And because of that, that the need to establish an economic mine required access to readily available water. And so that helped um, inspire his synthesis of a lot of these traditional mining practices coupled with regenerative farming. He was especially active in Australia in a time where the land base had been undermined largely due to poor agricultural management. And so a lot of his work was concurrent with the Soil Conservation Service's conservation and restoration efforts. But as Yeomans framed it, it wasn't nearly enough to conserve the soil and water resources of the Australian continent. Following all of this misuse and mismanagement, it was really essential to regenerate those resources. And so as a result of that, he conceived of the Keyline plan, and he was a fairly prolific author over the course of his lifetime. Here's a number of his books on the subject, most of which are out of print, although you can access the top four at a website called soilandhealth.org, where you can find all sorts of out of print books in PDF form on regenerative and organic agriculture. His sons have since taken up that mantle, continuing to publish some work on Keyline and also continuing to produce the Yeoman's Keyline plow. And so just to start off with some terminology, uh, Keyline first and foremost describes a holistic design system that looks to the topography of the landscape to inform the design of the farm and homestead infrastructure. That could be the access and circulatory pathways. It could be water harvesting infrastructure or any cultivation patterns. It could be plantings, etc. Um, Keyline also describes a physical point in the landscape, or technically it would be a plane in the landscape. The keyline, it's the inflection point in a valley. It's the contour line passing through the inflection point in a valley. And we'll get into that in a little bit more detail in a moment. And then third, the name keyline also describes Yeoman's specialized design for a subsoil plow. And so, we see, we can talk about keyline design, finding the keyline in the landscape or key lines in a landscape, and also the use of the keyline or the yeoman's plow as a tool to help, restore structure and water holding capacity and and facilitate root development using a subsoiler. And so one of the core elements to the Keyline plan is Yeoman's scale of permanence, which was this really insightful way of organizing all of the characteristics and features of landscapes, of managed landscapes, based on those things that are, relatively more difficult to modify or change, and alongside their relative temporal permanence. And I tend to not to get too hung up on the respective, um, placement of these different elements. Um, First and foremost, climate is the big one that we have little, if any, control as individuals to modify it. It um, is something that's fluid and is constantly in some state of flux, although there are obviously patterns that are somewhat predictable, that we can design in response to, but it is very much a response on our end. And what we see next in line along this scale of permanence would be the land shape or the topography or not necessarily just the geology. There's really we're talking more about the landform, the shape of the landscape that we can modify the land shape of the places we inhabit, but it takes a lot of energy in order to do that. And if we think about, that time scale on which they've expressed themselves, it's very much something that's, relatively permanent in relationship to a human time scale. And so what follows from that is that it behooves us to respond to the landscape rather than impose our will on the landscape, because the relationship of water's movement across the landscape, our access patterns, potential locations for plantings, etc., are all going to be affected by the shape of the land. Let's pay close attention to it, and when and as possible, try to respond to it instead of ignore it or intentionally kind of motor against it. And I'll just add that the scale of permanence is something that's been modified several times through history. Dave Jacke and Eric Tonesmeyer in their Edible Forest Gardens books did a modified version of that added a few specific elements. Darren Doherty and his company, the Regrarians, have also done something to kind of update and repackage that scale of permanence. Nonetheless, we see a lot of the same elements still expressed. And as far as like its utility, it's a really fantastic site analysis guideline, helping us break down landscapes into their constituent parts and then really think strategically about each of those and how they together, comprise the greater whole that is any piece of the earth that we may be interested in understanding better and tending as conscientiously as we can. So as we start to get into a little bit more of the nuts and bolts of Keyline, the foundation is the geography of Keyline, and it's comprised of just a few simple shapes. Um, the basic building blocks of Keyline's geography would be ridges and valleys, and they're terms we're all very familiar with, although this may be a little bit of an adaptation um, for some of us because in this context, a ridge is simply any convex landform. This could be a speed bump. This could be, a piece of ledge sticking out of the soil. And it could also be the spine of the Green Mountains or the White Mountains. Um, and so a ridge is any convex landform that's going to naturally shed water. And in contrast, in this case, a valley is just any concave landform that's going to be receiving water. And so it's less about where they're located in terms of like elevation in the landscape. It's more just about the actual physical shape of the landform. Does it receive water or does it tend to shed water? And so the main building blocks of Keyline's geography would be akin to our spine and ribs in our bodies, or the top of our knuckles, along our fist, and our fingers and the spaces between them on our hands. What we would describe as the main ridge of the landscape being like literally the spine of the landscape. We see that in this grainy illustration here from Water for Every Farm. And then just like our fingers radiating off of that ridge of metaphorical knuckles, we have primary ridges that are um, intercepted with primary valleys between. And so literally it is like, a series of fingers across the landscape that create that undulating pattern of water collection, drainage, distribution. And of course, in reality, things get more complex. We'll have secondary and tertiary ridges. Um, Things don't necessarily translate exactly as it's laid out in this kind of simplistic way, but nonetheless, the pattern is very much consistent. The other main element that we see present in this slide here, these stars or asterisks indicate what's known as the key point. And key points are technically only located in valley shapes, so we don't see them out along ridges here. But what they denote is the transition of a slope from being steep and convex in profile to flatter and concave. And we see that at both of these points where the contour lines transition from being close together to getting a little bit further apart. And so if we were to take a cross-section view through there, take a slice through it, we'd be looking at a slope like this. And our key point is going to lie somewhere in around that area where we reach that inflection between steep and convex and flatter and concave. And, we see this pattern etched into the landscapes all around us, throughout New England, because often that is the edge of field and forest. It's where the clearance pattern ended. In a lot of cases, because once we start to get up into those, steeper uplands, they're just less suitable for agriculture. They're more erosion prone. They're harder to manage with machinery. Um, and it can often be a place where springs will express themselves in the landscape or the water table emerges. The key point also represents from a water harvesting perspective, often a very efficient place to store water in the landscape because we have that natural convex shape. So if we were to build a farm pond or an earthen dam with an embankment or a berm that's shaped from the subsoil, the clay-rich subsoil that hopefully lies below, um, we already have that natural hollow shape. That means ideally we don't have to build as big of a berm in order to capture and back up a much larger volume of water. So it's not always true, but often key point ponds or key point dams can be very efficient places for us to store water. They can also the key point can also offer us a really valuable planning plane that can inform subsoil plowing passes and or agroforestry, planting layouts or just the layouts of grazing paddocks, access ways, etc. And so the key line, as you see here, is the contour line that passes through the key point. And so assuming that you have a, a primary valley on your site, where the key point is expressed, that inflection point from the convex to concave, um, we lay out that key line passing through the key point, and that can provide us with a very uh, helpful planning plane to inform a lot of other patterns. And what you start to see in this case, where we're mapping out potentially these would be rows of trees, although they're pretty tight together in this context. So this is more likely denoting the passes made by the shanks of a subsoiler. What's interesting is if we only follow this single contour line to begin with, as we move higher up in the landscape, we find the pattern is no longer along contour in a true sense. It begins to drop and cross the contours from the valley out towards the ridge. This is where people often get a little bit confused. We're going to revisit this from a couple of different perspectives. And of course, we're also going to be exploring this in person in the workshop on Sunday. So there'll be plenty of room for Q&A when we are all together. Um, and we're approaching Keyline, we're talking about this big subject. We're trying to condense it all into an hour talk. So some of it I just have to kind of touch on and revisit. Um, but when we think about this geography of Keyline, we can think about it in a couple of different ways. One is just that like big picture land planning perspective. The other would be just very much more specific things like trying to restore soil through the use of a subsoiler. Um, if we look at an illustration like this and we see just kind of this natural expression of a watershed or a water catchment, one of the ways that Yeoman's conceived of Keyline being expressed is just helping slow and intercept that natural movement of water from the source or the uplands, the headwaters down to the sink or the low point in the landscape. And so here we see this sketch illustrating a series of ponds that are interconnected, capturing that surface runoff, and then just kind of slowing it so that we increase groundwater infiltration and aquifer recharge, and just help balance out the tendencies toward flooding and or drought. Here's uh, a topographic map of one of Yeoman's flagship farm properties called Yo Barney, named after his children. Or actually, the it's a contraction of the two family names in this case. Um, but you'll see as I hit this little dissolve blur in how you have to kind of pick a spot on the map, and what you'll note is where farm ponds have been located. And again, you have to spend a good bit of time with this to really understand the connectivity between them, but just to recognize the series of tiers capturing water as it moves from the high point, which is in the top left of this image, down towards the low point, which would be the right and the bottom edge. And this is what that farm looks like from an aerial perspective. You can make out perhaps this pond here, located in a valley shaped drainage. There's another one below it, lower in the drainage with a berm. It's been created from earth. It's been reshaped to cause the water to back up here. Very efficient place to store a considerable amount of water. But not only do we have these individual ponds, but in several cases, they're actually connected by diversion drains. So the spillway from the pond actually becomes a feeder, collecting both runoff off the slope above, but then also conveying it across to the next pond in that series. And so we're really, in this case, looking at creating a landscape with maximal surface water storage for gravity irrigation, and then also just really minimizing any runoff, trying to infiltrate into the soil or capture and store water in surface storage as much as possible. And Darren Doherty's uh, taken some uh, gone to some lengths to then help map out more clearly what some of the connectivity is between these individual ponds. And so we have the blue lines with the arrows along them indicate those overflow spillways or diversion drains that are in many cases connecting ponds to one another. And then the lines with the perpendicular ticks to them show the location of irrigation channels that would also be at a low angle gradient, but that would allow for flood irrigation from lock pipes buried within the berm of the pond. Mind you, not all farms are going to need to install systems even beginning to resemble this. And in many cases, often in New England, we have adequate rainfall throughout much of the season. And so the need to store water and surface storage like ponds may be a lot less necessary. Nonetheless, we can still begin to take some inspiration from the potential of what this offers and also imagine how with shifting climate or in a different context, something like this may be, exceedingly appropriate and may really help add, degrees of resilience to an existing farm. And then Darren went on to take this illustration one step further, showing how the subdivisions created by these diversion drains and irrigation ditches then may also help inform the layout of contour strip forests for silvopastures as well as grazing paddocks. And so, what builds from this is if we take um, ourselves back to that, scale of permanence overview a moment ago, the landform and the hydrology inform the subsequent elements in that scale of permanence, like the access ways, the fencing and some of the paddock delineation along with the vegetation. And so the key to understanding the keyline patterning is the simple recognition that naturally water is going to flow perpendicular to contour, meaning it runs downhill. Downhill is literally a plane that is perpendicular to contour. Water is going to tend to find the shortest path from the source down to the sink. And so in this illustration here, we're looking at, we have these curvy contour lines and then these kind of more top left to bottom right looking lines to show the theoretical path of, raindrops as or runoff as it makes its way from what here is a ridge down into a valley. And so these lines are always going to follow perpendicular to the contour, which means water's flowing downhill. What follows from that is that water is naturally running off of our ridges and concentrating in our valleys. That our ridges, tend to be drier and more exposed with shallower soils because soil is generally going to be eroding off of them, whereas our valleys are going to tend to have deeper soil and be more humid and moist. And so we get this kind of natural, um, variation in soil depth, some cases fertility, but definitely hydrology. And so what part of the goal of Keyline is to um, understand these patterns in order to try to more evenly distribute water across the landscape so that we don't end up with, soggy, wet valleys and then bony, dry ridges. That, we kind of ameliorate some of those extremes and spread the water out more evenly across the landscape by trying to humidify the ridges. And so that's what the pattern ultimately aims to do, is to drop from a point higher up in the valley to a point lower down on the adjoining primary ridge. And so in this case, we see a key point here in this valley. And I've taken some liberties here stitching together two different images that don't quite go together. But if we presume that this contour is consistent, what you'll see here is is a pattern that's that's dropping from a higher point in this valley. And as we head on down this way, we're crossing these contours out toward the ridge that are patterned, following that initial keyline layout, which is truly on a contour line. Every other subsequent pass, be it um, a parallel row of trees, or a fencing paddock, or a pass with a subsoil plow, they're all going to be off contour. Once we start to run parallel to a single contour line, all of our other uh, passes are going to be off of that contour. They're going to be parallel to it. And what we are aiming to do now is create this falling pattern from valley out toward ridge so that ideally we're gently redirecting or drawing water resources out from those moist valleys out towards those drier ridges and holding the water out on the ridge. So let's just really try to simplify things, because I know at this point some people's heads are probably spinning. So here we're looking at a contour map. We're over in the Champlain Valley and maybe Panton or Ferrisburg or something. It really doesn't matter for this sake. You might be able to make out there's some curviness to these contours here, indicating a valley that's draining off in this direction. But if we're really focused on this field here, broadly what we see is, um, we're heading out onto this broad ridge. Water is going to be draining down in this direction to the low point. And if we were just to vastly oversimplify our options for patterns to one of two options, we could either orient things running like this, or we could send them running like that. Again, we're just looking at the two extremes. So we have this versus that. And so now I'm asking you in your minds to answer, which do you think would be more advantageous for mitigating erosion, helping store um, runoff and water in the soil? And I'm guessing most people are probably pointing to this one, which, while not truly perfectly on contour, it's pretty darn close to on contour. We're looking at, parallel rows that more or less follow the contour. And for the sake of simplicity, especially when machinery is involved, straight lines actually may do an adequate enough job. Once we start to introduce a lot of curve, things can get a lot more complicated. And we can clearly see that this would probably be the best option if you're trying to move water as quickly as possible down the slope. Um, and there could be reasons where that's important, but there's also probably a number of situations where something like this is going to be far more preferable if we're really trying to buffer ourselves against the uncertainties of climatic patterns from season to season. Now, let's say we're looking at a landscape that's a little bit more complex, where we have, at least one very clear primary valley that's bookended by primary ridge and a primary ridge. So these are like the fingers with the space between the finger here. And so water's naturally concentrated in this low spot and being conveyed down the slope. The road also is acting like a little bit of I guess we have a ditch along the road, it looks like too. And so in this case, we're starting off with what we're choosing to be the key line of this part of the landscape. We can see the contour lines are relatively close together here. And then we get a much more pronounced variation in the distance between the contours. Um, so I've just kind of quickly mocked this up for this course, and it doesn't actually work perfectly. But if we decide that this is our key line, what would then follow, these again could be rows of trees and an alley cropping agroforestry system. It could be passes with the subsoil plow, or other kinds of field work. But the keyline pattern is going to give us some symmetry between the row spacing itself. But once we kind of replicate that pattern as we move up the slope, find that we're no longer following a true contour. But by the time we get to this fourth interval beyond, we are starting at this contour line, but we're actually dropping as we head down slope and crossing contours, so that we're having the effect of gently bringing water out toward the ridge from the valley. And it doesn't actually work on this side. It's something I'm going to need to play with more. For some reason, that pattern isn't quite aligning because, as I mentioned earlier, the landscape tends to be more complex than what we may read in the book. So it often can take a little bit of tinkering, but the idea still holds true. And so I know some people are still probably wondering, well, why are we thinking about these patterns? What are the practical applications of this? And there's going to be a few that we'll talk about tonight. The first and foremost, we're going to talk about the use of a subsoil plow as a way to, help remediate and restore the texture of of existing agricultural soils, and also as an attempt to redistribute water along this sort of path of least resistance. So there's an image of what a yeoman's plow might look like. Um, and I'd like to start off with this just as a reminder that when we think about what a healthy soil is, 50% of a healthy soil is not the media itself, it's the spaces between the particles. It's not the clay, silt, sand, or organic matter. It's the pore space. Um, and having those spaces for air and water are really essential to, thriving soil biology and healthy plants. But over time, because of repeated tillage or heavy machinery use or overgrazing, we've compacted our soils and we've squeezed out a lot of that pore space. And so it becomes really important for us to help, undo that compaction, in order to help kickstart our soil's ability to produce healthy, rich, vibrant plant life. And a subsoiler is a mechanical way for us to help accelerate that process of soil decompaction. So I do like to say that subsoiling in and of itself isn't necessarily a silver bullet. Ideally, we're addressing key limiting factors on our site, or the weak link that we're always trying to address. What is the weakest link in our farm ecosystem first? For many people, subsoiling is probably an issue because most of us are inheriting landscapes that have this legacy of kind of overuse. Maybe it was tillage during, wet times of year, or manure spreading when the soils were, exceedingly saturated. So soil compaction is one of those limiting factors that definitely would call for subsoiling, or some other form. You can use deep tap rooted plants like tillage radish, as ways to, leverage biology, help mitigate compaction over time. Plant life generally is going to help undo that. Um, Subsoiling is just a way to, mechanically do it and approach it in a more strategic and shorter time frame. For a lot of farmers during many seasons in Vermont that I've worked with, having too much water in parts of their fields have been a limiting factor. And so they're looking to accelerate drainage, which also may be a function of legacy compaction on the site. Many parts of the world, people are looking to address the issue of too little water on their landscapes. And you don't have to remember back too many seasons before, the realities of, borderline drought in New England, are also part of our experience. So trying to make sure that we're able to, infiltrate as much water as possible and rebuild that soil sponge that's able to just capture and hold as much water as possible. Low biological activity could also be a limiting factor, but just existing management might be another one um, if we're doing some type of rotational grazing, perhaps. There's just some inefficiencies and the recovery period that we're allowing, or the size of our paddocks, and um, the frequency of moving our animals. We may have just poor fertility or nutrient imbalances, low pH. These could all be limiting factors. So just to say, take the time to really try to think through what are all of your limiting factors before you just start tossing solutions at a problem. Um, but if compaction, waterlogged soils, droughtiness are some of those limiting factors, then subsoiling may be a great strategy for you. One way you can try to discern the relative compaction on your site is by using a penetrometer, a soil penetrometer, which is a handheld probe with a pressure gauge on it that allows you to stick it in the ground and get a relative reading for how compacted are your soils and at what depth are you reaching that compaction threshold. And from what I understand, about 300 psi is the level that agronomists generally say plant roots will struggle to grow. So you could perhaps borrow a penetrometer from local extension, um, and probe around to just get a relative idea of how compacted are your soils. Um, and Yeomans came up with the design for his plow that will contrast with some others a moment ago, as well as like a protocol for trying to help uh, deepen the biologically active, a horizon of the soil, the topsoil, through this remediative effort. Um, and the idea generally was aiming for 1 to 2 passes with the subsoiler per season over the course of 3 years, going incrementally deeper, starting off just a couple inches below existing plant rooting depth, or what seems to be sort of the most biologically active part of our soil. Um, and then going subsequently deeper with each respective pass, being careful to do it during the right time of year, meaning the soils aren't waterlogged, or just exceedingly wet. Try and make sure we're not doing any damage in that regard. So it can be a little bit of a dance to find those windows. But we'll often find at least 1 or 2 per season where that can work. And this is just to say that you don't need to use the yeoman's plow to, or the keyline plow to keyline plow. Um, but they do make a very nice subsoiler. So in this image, we see a bunch of different examples of subsoil plow shanks with the yeoman's shank here on the right-hand side. And the key things that you'll notice about uh, the yeoman's shank is it's relatively thin profile, which means it takes less horsepower to pull it and also creates less surface disturbance, and also a pretty shallow angle at the base of the shank. And what's missing here is the knock-on point that helps increase the shattering effect of the subsoiler below the surface. Um, and so you can use any subsoiler, um, but you'll generally tend to require uh, a less heavy duty tractor and also create less disturbance if you're able to use a shank similar to the one designed by Yeomans. In some cases, people choose just to purchase the shanks and outfit them on an existing toolbar they may have. Um, and we'll get into a little bit more of the components in just a moment, but here you see a yeoman shank engaged in the ground here at maybe 14 inches depth. Um, and in this case, it's being pulled because it's only like a 30 horsepower tractor. So we only have 2 shanks mounted on this toolbar. We've got some seed boxes behind it, depth wheels. You can't make out the coulter discs, but those perforate the sod beforehand in order to just help leave a real clean finish. And this is just an example of, compare and contrast of the surface finish of a yeoman's plow versus a chisel plow, which is, I don't even know technically if we consider a chisel plow a subsoiler, just because they're not really designed for deep tillage. But you're going to be very limited in terms of depth and also create a much more bumpy, irregular surface using a tool like that. Um, Over the last few years, Abe Collins, along with a number of other folks, have been working to develop the Vermont Rip Sower, which is a modified version of the subsoiler platform manufactured by I think it's the JM uh, Shirk Company, I believe, out of Pennsylvania. And so the Vermont Rip Sower is, um, in some ways, like kind of a cutting edge example of this integration of three different practices, all being administered with a single pass of the tractor. So in this case, we have a much more um, uh, compared to the shank pot seeders that you saw a second ago on the yeoman's plow, a much more higher precision um, seeder mounted in the wake of the subsoiler shanks, coupled with liquid fertilizer injection alongside that seeding. So you're getting, three different functions from just a single pass. And I know they were awarded a grant through the U.S. Department of Agriculture um, to help develop some of the R&D on this machine, and then also get some of these machines out into different parts of the state. And so it may be that you're in proximity to someone who is now an owner of a rip sower, or at least has one that you may be able to observe in use. I've seen some workshops that have gone on over the last couple summers as well on the use of the rip sower. Um, but just to say that there are a number of tools that can help us achieve this same effect. And in practice, I'm the owner of a Keyline plow, and I've done some custom subsoiling for farmers over the past 15 years. I also offer it for rent during the summer months. And so when I'm uh, new to a property, generally speaking, I begin by identifying a key point. Often it is a key point if they have one, but there's not always a key point to be found in a field, like a true key point in the yeoman sense. So I identify a strategic point to, you know, originate my pattern, and then use a laser level to find the contour that passes through it. And then basically follow along that contour line for my first pass with the tractor. And then I can pull up those flags or stakes, and every other pass runs parallel to that original contour line. And so that's kind of the essence of subsoiling in a keyline context is, we establish the pattern, and and then, once we do that initial pass, everything else follows parallel, presuming there aren't major changes in the land shape along the way. There's a lot of caveats that I'm not going to get into right now, but just to say once again that there's undulations in the land that aren't accounted for in the geography of Keyline, and sometimes you really need to not let the perfect be the enemy of the good, and find the pattern that is roughly right, um, and that will generally achieve your intended function. That said, you may also choose to subsoil plow paying no attention to the keyline patterning. Um, it may well have impact on drainage. So that is something that you want to take into consideration. And the idea with the keyline patterning is that in some ways, you're creating drainage, but you're also trying to disperse water more evenly across the landscape, as opposed to just taking the shortest path to the low point in the landscape. So we just addressed keyline patterning and subsoiling, but the keyline patterning, as I mentioned earlier, could also inform the design of the whole farm. And so here's an example of GIS based, like early stages of a GIS based design for a colleague's farm that is no longer active, as I understand, but was pretty cutting edge going on about 10 years ago in Iowa, called Versaland, some Grant Schultz's work. So here we're looking at a valley, and we've got a ridge and a ridge here. Water is draining from the top of the map downslope. And they've clued in on a key point right here. deciding that the contour lines are shifting between being close together and further apart, and highlighting that contour line as their key line. And so if we head over to the right, we can follow the scales shifted a little bit. We can follow where that key line is and see how then they went on to try to lay out parallel laneways between that will be used for making hay with rows of trees, the blue lines being rows of trees. And this does hold out better than my example a moment ago, where if we trace one of these lines, once we get beyond that initial key line that is truly on contour, we see that as we make our way out toward the ridge, the pattern is dropping and crossing contour lines, meaning that we have the effect of these rows falling out toward the ridge, meaning if you had a hose running at the top end and this was an open ditch, water is going to be gently drawn out toward the ridge from the valley. We're not moving uphill, we're moving downslope from the valley, but out toward the ridge. And see here, we're crossing these contours. And this is a good example of how, again, the map is not the territory, or the landscape is not the textbook. Um, in order to maintain that relative equidistance and still have the same desired effect, they had to stub in a small little segment here, because that pattern was going to become too exaggerated. Um, there are a number of ways that one may choose to go around that. One might be just to maintain this ridge as an access lane and not have to deal with that sharper transition. That we have two different segments of rows that traverse along here to the access lane, and then here. We'll probably get into this a little bit more in the workshop. But now zooming out, looking at the whole farm, we can see how this patterning is informing the rows of trees with the alleys between for haymaking and or grazing, as well as the location of strategic ponds that are placed for potential irrigation during dry periods, or watering points for livestock, and just overall resilience on the farm. Um, and so this is all something done using CAD or GIS software. And then what they went on to do was to take the modern technology being used by a lot of row crop farmers and integrate it into this, regenerative farm patterning, using tractors equipped with auto steer technology, and then a single subsoil shank as a way to, etch the pattern of their design into the landscape. So the tractor is they've uploaded the design to the tractor's onboard GPS, and then the tractor simply follows the rows as they were laid out, not unlike what they might do when creating like a corn maze, or just um, precision planting, which is, as I understand, how much conventional agriculture is being done these days. They've just kind of re-rigged it to employ some of this regenerative agricultural patterning, which was pretty cutting edge when they were doing that, first maybe 12, 14 years ago. There could be other reasons why we're laying these patterns out. In this case, these are kind of mini swales, mini water catchment features along a hillside. And in this case, these are not following keyline, they are true contour lines. And so that pattern is informed by the topography, and then ultimately being represented by the nature of the planting pattern that'll go in here. So this is for a shelter belt or hedgerow, and the tree planting follows the topography. And this is a great opportunity then to just take a moment to compare and contrast the difference between contour layouts and keyline layouts because they're very similar, but they have different effects. Um, and so here we're looking at an agroforestry layout designed by Darren Doherty in Australia. And we've got a valley running through the landscape right here. And there's a primary ridge right here and another valley right there. And what we see, these little white dots are tree tubes. So we're dealing with rows of trees with um, hayfield in between or row crop. I can't recall what's going on here, but more or less you can make out the equidistance between these rows, which makes this something that's very well suited to any kind of mechanized farming. Let's just say this, I've just stylized some potential contour lines across this landscape. I'm sure they're not super accurate, but they make the point at least. If we were to do a similar thing, kind of an alley crop agroforestry system, but lay out our rows following true contour lines, what you'll see is the reality that, very rarely are contour lines going to be equidistant from one another for any significant interval, especially as we start to stack up multiple contours. As things get steeper, the contours get tighter together. As they get flatter, they're further apart. And so if these were rows of trees, you're kind of boxed in to do any field work in between those rows. It becomes very inefficient because you may only have a single pass through this little narrow straight, but now you've got, all these irregular shapes happening as things open up. And so that just really, whereas you are getting kind of, perfect water capture and infiltration if you're laying everything out along contour because it's perfectly level. With Keyline, you're able to balance symmetrical rows, just like you would get in a field where you've got, straight north-south rows or rows that are perfectly straight following an existing road. What you also get, as we've talked about, is that reality that the keyline pattern should be gently falling from valley to ridge. So, whereas with contour, water just being theoretically intercepted as it flows down the slope equally across the entire slope. With keyline, the idea is that we're gently redirecting water out towards the ridges to hold it in those drier parts of the landscape and to help to just facilitate a little bit of drainage in our wet spots. So that's, kind of a brief compare and contrast of what um, contour and keyline layouts would offer. For some folks, this whole design process can be as simple as kind of a quick sketch or back of the napkin kind of design, and literally some seat of the pants plowing. In this case, we're just using a single shank moldboard plow to etch that pattern into the landscape that we see in the previous slide here, which is just a series. Well, there's a single pond along the main ridge of this landscape. We've got a couple of primary valleys, and then rows of trees that follow across, more or less across the contour. And so he's creating very definitive water catchment feature, a swale, just by using a single shank moldboard plow along a surveyed contour line. And it's as simple as that. There's no auto steer technology. I don't know if there was even much subsoiling that went into this. Um, but then, of course, for a lot of farms, there may be a lot more sophistication. And so, the whole design process may require a lot more technology or planning, as well as the implementation. So looking at something like New Forest Farm in southwestern Wisconsin, started by Mark Shepard and family. Um, One example of a keyline designed farm. We haven't talked a lot about access today, but Keyline offers some really good insights to how and where we place access, often striving for ridges as good places because they offer us connectivity to both sides of the respective watershed. Also, perimeter roads, especially important for headlands, for being able to turn equipment around. Um, and so some of this, the circulatory system of the landscape can be a really valuable way to break it up into smaller pieces and then ultimately inform different um, land management units as well. Just another example of some of Darren Doherty's work from, probably a couple decades ago, but we see in this case a access road that's also serving as water catchment and diversion, feeding this upper pond. We've got keyline layout, some vineyards, etc. I don't know that this was actually ever implemented, but a friend and colleague of mine, Brandon Bless over at Bread and Butter Farm in Shelburne, um, I know they've probably been doing a lot in the years since. This might be almost 10 years ago that Brandon first shared this image of one of his keyline layouts for, I believe this was just really more for paddock management on the farm. I don't know if there was any planting that was going to go on here, um, but just modeling again that symmetry. This is just done on Google Earth, which is free technology that's pretty readily available to folks and fairly user friendly. Um, Richard Perkins is the name of a regenerative farmer and author that has employed keyline as the foundational pattern for the layout of his the agroforestry elements on his farm. Again, here we can make out a primary valley with ridges on either side and that symmetrical row spacing between. Um, Abe Collins uh, developed a pretty innovative design for a commercial dairy farm up in Swanton, going back probably 15 years ago, where we had a massive pond slash, small lake at the low point of the farm, which became the collection point that could be pumped using wind turbines or windmills to a high point pond that was then available for gravity-fed irrigation to these long-running paddocks that were um, regraded to drain quite precisely from I guess generally from west to east. And that's just one example of a local dairy farm that was designed according to some of these principles. And the next step is for us to figure out how we apply this to our own respective landscapes. In this case, we're looking at a satellite image of our host farm over in West Woodbury, and we're seeing both I think these are the USGS 20-foot contour intervals, along with the now uh, freely available LiDAR data with 1-foot contours for the entirety of the state. Um, and so, if you want to spend a little bit of time with this, I encourage you to pause this talk and study the map here a little bit and try to make some sense of what's happening across this landscape. I'm going to wrap this up just with a little primer on how to use the Vermont Agency of Natural Resources Natural Resource Atlas, and invite you to bring in a map of your site if you'd like to be able to discuss it during um, the last section of the course on Sunday. I'm going to stop sharing my screen here, and I am going to reshare my browser here, and we're going to just open this up. If you search Vermont Natural Resources Atlas, you're going to come to this site, and it takes a minute to bring it up. And then you can enter whatever your address is here in the toolbar or in the search bar there. And I'm just going to pick a random spot. So if you entered in an address, it's going to spit it out right here, and you can click on the address and it should take you right to your location. But I'm just going to pick a place on the land in the landscape. And one other really cool thing about this is that all of the property boundaries are built right into it as well. So you can, click on a parcel and it's going to tell you what the acreage is and the listed value and land use, etc. And so where you're going to want to go is you're going to hit this quick tools thing here, and you're going to go to show map layers. And that will open up this pane over here, panel, with all these different layers that you can toggle on and off. In geology, you've got landslides and bedrock outcrops and quarries and superficial geology and soil, different qualities of soil types. Show you where your prime ag soils are. It's going to show you where different soil types are, etc. But for now, what I'd like to ask is you start off with the VCGI map service contours that are going to give you those, often they're 20, in some cases even 50-foot contour intervals. So they're not giving you a lot of detail here. What they're telling you, especially if you zoom out a little bit, they're giving you an idea of like the broad pattern of the landscape. But we're zooming in a little bit because we want to know about this part of this parcel. And we have no contour lines in that space. So we're going to turn on the LiDAR data where we have 1-foot contours. And you have to take all this with a grain of salt, but they are surprisingly accurate. And so from this, now we can make out a lot more detail about the nature of this landscape. If we click on an individual contour line, it's going to tell us what that elevation is. So that's the 410-foot contour. And just to make sure we're looking at it correctly, well, that's 412. So as what's suspected, this is a valley draining in this direction. And we've got a bit of a plateau or ridge happening right over in here. And so now we can really start to imagine how Keyline might inform an agroforestry layout that would happen in this field. Because we have this powerful, without this information, at best we have this, which tells us nothing. And at worst, we don't even have that. Um, and so thank you to the state of Vermont for making this available to us and making it so accessible. I hope that that was enough of a primer for you to be able to understand. If you're on a Macintosh like I am, you can hit Control or you can hit Command Shift 4, and that'll turn your cursor into a little a thing that'll allow you to capture the pane you select with your computer, and that'll give you a screenshot and you can print it. You can also just print straight from your browser if you wanted to print this map out to be able to bring it in. But even if you don't bring it into the class, it'll be really good to familiarize yourself with this because it's a great way to gain a deeper appreciation for your own landscape. So I hope that gave you a good foundation for the fundamentals of Keyline. We're going to explore all this out in the field. We're going to revisit it in brief at the start of the workshop and do my best to answer your questions. It's a really exciting concept. It can be very confusing too. And it's one of those things that, it continues to build as you gain more and more understanding of these foundations. But I think there's a lot that we can learn from the brilliance and the genius P.A. Yeomans and the Yeomans family and Darren Doherty and some of the other people who have been who really helped pushing this state of the art and just exploring how we can ally ourselves with the landscape and be conscious co-participants in the succession and evolution of the ecosystems we're a part of. So thanks very much for your attention, and I look forward to seeing you on Sunday.